Today's lesson is on how to determine shapes of molecules from Lewis structures or Lewis dots. And we're going to actually use the Lewis structures for today's video, but you can also do the same thing with Lewis dots. So we already did this in class, but what we did instead of determining them from the Lewis structures, we determined them using the model kits. But you're not always going to have your model kit in your back pocket. So you need to have a way to determine the shapes from something else, and in this case from the Lewis structures. Shapes are really, really important for molecules. It determines a lot of their properties. For instance, as we said in class, water is bent, but if it was linear, there would be no life on Earth. Why is that? Because it's bent, it makes water polar. And because it's polar, it gives water many unusual properties. One is that we have liquid water on Earth, and scientists still believe you need liquid water for life. So without liquid water, water would just be a gas. Wouldn't have any liquid water, so no life on Earth. So very important shapes. So how are we going to figure them out? Well, to do that, you need several things today to follow along with the video. So what do you need to have with you? You need to have this sheet, which is problem book 415. And these are the molecules that I gave out in class that you were supposed to draw Lewis structures. Those are the ones with the dots and the lines. And you were supposed to figure them out and put them on the sheet. If you haven't done so already, pause the video and go ahead and do that. You're also going to need to have your 5 marshmallows and your 4 toothpicks to fill out this chart. So go ahead and pause the video if you need to, and then come back and join us when you have all your supplies. And I'll be here. So, welcome back. I hope you now have this chart, which you should have already filled in. So this is what your Lewis dots should look like. So if you need to pause the video again, check your Lewis dots. Are these what they look like? All right? Because we're going to use these to determine the shapes. Now, how are we going to use a flat two-dimensional drawing to determine the shape? Well, that's using a famous theory, and that's called the valence shell electron pair repulsion theory. So write this down somewhere. You can write it on the back of 415. Valence shell electron pair repulsion theory. And once again, Miss Backus has a pet peeve, and one is the name of this theory, because unfortunately they use the word pair, and it really should say group. So valence shell electron group repulsion theory. So valence shell is fine. Those are the electrons in the outer shell. We're doing that. And they repel each other. So they want as much space between them and the next orbital. And this is given an acronym VESPR, V-S-E-P-R. But we're going to really use groups of electrons because a single bond has a pair of electrons. But a double bond has 2 pairs of electrons, but it's still considered one group. A triple bond has 3 pairs of electrons, but it is still one group. So this really should be valence shell electron group repulsion theory, because the groups of electrons are going to repel each other, and that's going to determine the shape. So we need to understand and how to count groups of electrons. So here is your sheet. And the first row has the same number of groups of electrons. And we want to worry about the central atom because that's going to be where the shape is centered around. So how many groups of electrons, not pairs, are around the central atom? So the first row has the same amount of groups around the central atom. So let's count the groups. Here we have methane, CH4. There are 1, 2, 3, 4 single bonds. Those are 4 groups, 1, 2, 3, 4 groups around carbon. What about ammonia, which is NH3? I still have 4 groups. I have 1, 2, 3 bonds, but I also have a pair of electrons. That counts as a group too. So I have 1, 2, 3, 4 groups of electrons. Water, 1, 2, 3, 4 groups of electrons. 2 that have single bonds and 2 that are lone, well, they're not lone pairs. They're just a pair but not bonded. And then I have chlorine, and I have 2, 4, 6, 8 electrons, but 1, 2, 3, 4 groups of them. So 4 groups around chlorine, 4 groups around oxygen, 4 groups around nitrogen, 4 groups around carbon. Now, remember, chlorine here, though, is not doesn't have a middle to it. It's just two atoms. So that kind of doesn't apply groups around the central atom. There is no real central atom here. So we'll come back to that. So all of these in this first row have 4 electrons around the central atom. So I'm going to put the number 4 here. So 4 electrons around the central atom. So what is the angle that 4 electrons can get as far away from possible from each other, still be symmetrical around the nucleus, and how are they going to do that? So this is time to take out your marshmallows. So take out a marshmallow, and you're going to take out your toothpicks, and now you're going to put 4 toothpicks in this marshmallow. Ooh, it got away. 4 toothpicks in this marshmallow so that the toothpicks have the biggest angle from each other. So you want the biggest possible angle from this center one, from each other. So put the 4 toothpicks in here, and they want to be as spread out as possible from each other. So pause the video and try to do that, and we'll come right back. All right, let's see how you did. Does your marshmallow look like, drum roll, this? Okay, does it look like this? This is the farthest away the toothpicks can get from each other. Although I did not do a fabulous job with this, but you should be able to tell in case you made this flat and you made these 90-degree angles. These are much bigger than 90-degree angles, right? So this is what it looks like. Here it is. This is the farthest 4 toothpicks can get from each other. If you made it flat, okay, that's not correct. So rearrange your toothpicks, push pause, rearrange them so your toothpicks look like this. I also am kind of cheating because I also have a model kit. You probably don't have a model kit at home like Ms. Backus does, but I have my model kit. So here is a familiar shape to you. These are the 4 electron groups around a central atom. And in this place it's carbon, but we can kind of think of this as a generic atom for the purposes of this activity. So here we have, that's how 4 groups can get as far away from each other. Look at the angle. It is not a 90-degree angle. It's farther than 90. So if you made this flat and you tried to do that, that's not correct. So it looks like this. So go ahead and make your marshmallow. So you get a little marshmallow guy just like this. Remember, at the end, you're going to take a selfie, which is a picture of you and your favorite marshmallow molecule that we're making today. All right, so let's go back to that chart. So what is this angle? It's bigger than 90. It's about 109.5 degrees, but that's going to vary a little bit between the molecules as we talk around. So it's about that. It can be different than that, but it's about this angle. All right, so that's as far as the electrons can get from each other. And it makes this generic shape, which is really, really important. So draw this here also. We have the central atom, and then I have the generic shape. This comes up, down, down, down. That's our little diagram right there. All right, so what kind of shapes does 4 groups of electrons make? So take your little toothpick marshmallow, okay? So take this, and now what happens if there's a marshmallow at the end of each of these? Because one, I just have the central atom, right? And so what is the shape right now? It's just a point in space, right? No really shape because I just have one. But methane has 5 atoms, 1 in the middle and 4 at the edges. So go ahead and add your marshmallows to your toothpick, pausing if you need to. Okay, I'll wait a minute or second, pause the video and come back when you're ready. All right, so your little marshmallow guy should look like this. Oh, he's so cute. All right, so there he is. Okay, turn it on its side. Sitting up right there. As you can see, there's a marshmallow. And I put my marshmallows so that the flat part was kind of down on the ground. Makes it stand a little nicer. So there we have the shape of methane. And we talked about what shape this was in class when we did our model kit. Do you remember the name of this? Hopefully you do. What's the name of this? This is a tetrahedron. So put in this under here on the side. This is a tetrahedron. All right, so that's a tetrahedron. I know it's kind of small in the video today, and hopefully if I say it and you can see it, it will work. All right, so methane has a tetrahedron shape. Okay, what about ammonia? It has 4 electrons, so it still has this generic shape, right? But instead this time, it only has 4 atoms altogether. So always put 1 in the center first, and then put 3 more marshmallows. Okay, so if you have this one already made, right? You already made this. Take 1 off. Okay, now what is the shape? The shape should look familiar to you, right? Let me move it away from this. So that's our shape. Okay, what shape is this? Hopefully you remember that's a pyramid shape. I'm going to write this in a little darker pen. Maybe that will help you out. That's a pyramid. Okay. I'm also going to show it to you with my model kit, since I have a model kit here at home. So here was an atom in the center. And if I have 4 atoms on the edges, we get our tetrahedron. Okay, so here is my tetrahedron. Okay, so I have 5 atoms altogether and 4 groups of electrons. And what happens when I lose one of them? Well, let's take off the top. Now I just have a pyramid. Okay, pyramid shape. Notice it is not flat. It is not sitting down level. Okay, it's a pyramid. All right, so take your shape now, and I think you're going to start to see the pattern. Here's our shape right here. Move this out of the way. But what happens if we go to water? Water has 4 groups of electrons, so it has 4 toothpicks, but it only has 3 atoms. So let's remove a marshmallow. And there is my shape for water. And notice the shape only involves the atoms themselves. So not the sticks are still there, the electrons are still there. So I still have electrons here, still have electrons here, okay? But this is the shape I get. And what is that shape? That's the bent shape, all right? So if I have water on my chart, this is bent, all right? Now, last one on this one. What happens if I only have 2 atoms? So I get to remove 1 more atom. And then this is my shape. And we just look at the 2 atoms themselves for the shape. And that is, let's remove this here. What's that? That's a straight line. Okay, it's linear. That's the only shape, let me hold it right. That's the only shape 2 atoms can have. What's the shape of 2 points in space? You can only make a line from 2 points in space. So this is linear. So we're going to save actually some time right now, because if the only shape you can have when there's 2 atoms is linear, I can fill in the rest of this. Okay, oxygen has to be linear. I can only have a linear molecule if I have just 2 atoms. There's no other possibilities. So I could have more than 2 atoms, but if I just have 2 atoms, my only shape possibility is linear. So you could have 3 atoms that are linear, but you can't have a different shape for 2 atoms. So linear, linear, linear. So I'm already down here. All right, so we filled in more of our chart. All right, so let's do the next row. So we're going to do the same procedure. How many groups of electrons around the center atom? So the center is carbon, and now I have 1 single bond here, that's 1 group, 1 single bond here, that's 1 group, and a double bond. The double bond is also 1 group. So I have 1, 2, 3 groups around this center atom. What about NOH? Nitrogen's my center one. A single bond, that's 1 group. A double bond, that's 1 group. And this pair up here that doesn't have a bond, but they're still there. So I have 1, 2, 3 groups of electrons. And here, it doesn't matter. It's linear, so I'm done. So what kind of shapes can 3 groups of electrons have? Well, once again, you need to take out one of your marshmallows. And this time, take 3 toothpicks, not 4, and try to get the toothpicks as far away from each other as possible, the greatest angle between them. So once again, pause the video and see if you can figure this one out. I think it's a little bit easier than the 4. So see if you can figure out the angle that 3 toothpicks, the farthest they can get from each other, coming out of one marshmallow. Pause the video if you have to, and then turn it on when you're ready. Welcome back. Hopefully you figured it out. Here it is. This is the biggest angle, 3 popsicle sticks, 3 toothpicks. I don't know why I'm having trouble with that, but 3 toothpicks can get from each other. All right. And this is a flat arrangement. Okay. They should be all in the same plane. If I hold it on the side, it is flat. And I didn't do this perfectly. Maybe I should adjust these a little bit, but the angle should be the same all the way around. Okay. And the angle here is, you know what the angle here is for a triangle like this? It's 120 degrees. So let's take that chart. So this is at 120 degrees. And once again, that varies a little bit between the molecules, but it's about 120 degrees. All right. And now I'm going to remember this generic shape. And I'm going to kind of make this a little darker so we can see that. All right. So this generic shape is like this. And this one is flat. Okay. So that's a flat shape. All right. So now I'm going to take my marshmallows and I'm going to add the right number of atoms. So what if I have 4 atoms all together? So I have 1 marshmallow in the middle, and so go ahead and add some marshmallows on the edges. So I'm going to add my marshmallows here, so you can do it while you're watching me do it. So I'm going to add a marshmallow at each edge. This one's a little easier because it can sit flat on my counter here. So there we have our shape, and it is flat, and these are 120 degree angles. So there I have my shape. So do you remember what we called this in class? All right. If not, it is trigonal planar. Trigonal meaning 3. Sometimes you see it also called triangular, another word for trigonal, and this is planar. Sometimes you see this called trigonal pyramid or triangular pyramid, and triangular or trigonal planar. So trigonal planar. All right. And then the next one, what happens if I just have 3 atoms? Okay. So always keep the center one. 1, 2, 3. So now I have to get rid of this one here. The electrons are still there, but there's no atom here. So the shape is determined just by this right here. So what is this shape now? This is bent. Okay. So notice this bent is different than this bent because this bent is at an angle of 109.5. This one is at 120, but they are both considered bent. Okay? And then this is linear. We've already said that. So we're almost done with this chart. So see if you can have the pattern. All right, so the next one, how many groups around the last one? Okay, so let's look at carbon dioxide, CO2. There's a double bond here around carbon. That's one group. There's a double bond here. That's a group. So I have 2 groups around the carbon. So I'm going to put a 2 here. And once again, take your marshmallow. So I'm going to take a marshmallow. Here's my marshmallow. And now I'm going to put 2 toothpicks. And I want them to be as far apart as possible angle-wise. So take this, take a second. I hope you're actually doing this. I'm not there in your living room or your bedroom. So I'm hoping you're actually doing this because it will just help you remember things. So if I say it and you do it, you'll find out, wow, I really do remember this a little bit better. Why? Because you actually physically made these. So that's why that's important. So pause the video if you have to. I'm going to make mine on the side. So see if you can figure out what it's going to be. I think this one is really easy, right? Okay, so da-da, there it is. The farthest 2 toothpicks can be from each other is 180 degrees, right? So there I have it. Okay? So I get this. And oops, it looks like I've put down my pen somewhere, so I'm going to use a different color again. So now I'm at 180 degrees. Okay. And this would be like, this is the generic shape. All right. So let's do carbon dioxide. There are 3 atoms for carbon dioxide. So I need to have one in the middle. I've got the one in the middle. And I need to add 2 more marshmallows. And there we have carbon dioxide, right? If you want, you could actually put 2 to represent the double bond, but it's not required. So I could have 2. And this does stay as a group together. 2. There we have it. So there we have carbon dioxide. Carbon dioxide is a linear molecule. Carbon dioxide is a gas at room temperature. It is not polar. And we're going to talk about that later when we talk about polarity. So let's fill in this last one. We're almost done. Thanks for hanging with me. So this is linear. So notice the only shape a molecule can be if you have 2 groups of electrons is linear. Okay? So then you say, but Miss Backus, do I have to memorize this or can I use this sheet on the test? Oh, so sad. No, you cannot use this sheet on the test. But I will tell you how it's easy to remember. I just remember this and use this to determine the molecules. So let's try one that's not on the chart and see if we can do it without the chart. But I remember this. If I have 4 groups, I have this shape. If I have 3 groups, I have this shape. If I have 2 groups, I have this shape. And then I go about adding the atoms that you need. So in your notes somewhere, pause the video if you need to, take down these steps. So step 1, you're going to count the groups of electrons around the center atom, right? Don't forget double or triple bond or single bonds. Those are all one group. And don't forget to count the unbonded pair. They're there too. That's a group. Step 1. If you have to pause to write that down, you can. Step 2. Remember these 3 generic shapes. This is the shape if you have 4 groups of electrons. This is the shape if you have 3 groups of electrons. This is the shape that if you have 2 groups of electrons. After you get the correct shape, so let's say I know there are 4 groups of electrons. I take my generic shape and I add the correct number of atoms. Do I have 5 atoms? If I do, this is what it looks like, and that's a tetrahedron. If I have 4 atoms, I add 4. 1, 2, 3, 4. Don't forget to do the center one first. That's a pyramid. If I have just 3, I get a bent shape. So I start with this and I add the number of dots. Do I have something at each end? Do I just have 4? Do I just have 3? What do I got? So here, from this generic shape, I get tetrahedron, I get pyramid, and I get bent. And you can do the same thing with the other shapes. So for the other shapes, if I have 3 groups, if I have all of these sections filled, it's trigonal planar. If I have 2 of them filled, so 3 atoms, 1, 2, 3, that's bent. And if I have 2 groups of electrons, the only shape that I can have is linear. So after I did that, go ahead and remember your shapes: tetrahedron, pyramid, bent, trigonal planar, or linear. So let's try one last one together. So pause the video if you need to, and let's do one together. So I'm gonna, let's see, need some place to do it. So let's do this right on the back of this sheet, okay? So here's the molecule we're gonna do. We're gonna do PSH. So the first thing I need is a Lewis dot or a Lewis structure. I'm going to do a Lewis structure. So phosphorus needs 3 bonds, sulfur needs 2, hydrogen needs 1. If you need to know how I got that, that's from the periodic table. So 3 bonds, 2 bonds, 1. So phosphorus needs 3, okay? Sulfur needs 2. Hydrogen needs 1, okay? So I'm just going to hook them all together. So I have phosphorus, and I could have done that. Maybe I'm kind of giving the shape away already. So phosphorus, sulfur, hydrogen, okay? Because if I draw it, it's flat. I could draw it this way. So let's take a look at this one. So phosphorus is in the middle. I draw hydrogen, draw sulfur, but then I notice I'm not done. Hydrogen's happy. It has 1 bond, but phosphorus needed 3. It only has 2. Sulfur needed 2. It only has 1. So I can add 1 here, and then phosphorus has 3 bonds, sulfur has 2 bonds, and that's good. This is structural, but I need a Lewis structure. So phosphorus has 2, 4, 6 already around it. It needs 1 more pair. Sulfur has 2, 4. It needs 4 more. So here I go. So that's what I have for the structural. Now I have to find the center atom, phosphorus, and count how many groups. 1 group, 2 group, 3 groups. So for 3 groups, I have to remember the generic shape for 3 groups. That's this generic shape. So remember, you need to memorize this generic shape. And these are 120-degree angles, and it's flat. All right? So in the middle, I have phosphorus, or I could just put P. I have sulfur at one end, and I have hydrogen at another end. So what is this shape then? If this is phosphorus, sulfur, hydrogen, and there's nothing here except electrons by themselves, what is this shape? That's a bent shape. It is not linear, so this is a bent molecule. So there we have it. I went from a formula to a Lewis structure to a generic to a specific, and I got the name. So that's how you do it. Hope you followed along. Now don't forget to take your selfie. Take one of your molecules. So maybe you would take water. So here would be water. Take a picture of yourself with your molecule and post it to our community page. That's called a selfie. Post it to our community page, you and the molecule, and put it under cool stuff, because I think that was really cool that you played along. So see you in class. Hope you enjoyed this video.